Okay, so exercise 9 is the exercise where they gave you the basic graph formula and they said, now this graph is being shifted in a certain way. And one is the equation. All right, so for the first one, they said, now give the equation if f, which was cos x, is shifted 20 degrees to the right. Remember, if it's to the right, then we do an x minus and 1 unit up. So guys, this will be a 2-mark question. Hey, how nice is that? In a test like that. 1, 2. Okay. Imagine the tips there. There we go. Okay, 2-mark question, yes. Your test is on analytical and trig, yes, trig graph. Okay, 1.2 guys, they now ask for the range of the new graph. Oh, we did actually do an example like this in class on Friday, right? They asked for the range of the shifted graph. And like I said, think of the range of the original graph. For the cos graph is negative 1 to 1. Right? So we find that. But now, because this whole graph is shifting 1 up, both of these values will be shifted 1 up. Instead of negative 1, you're going to have 0. Right? 1 more than negative 1. And instead of 1 for your maximum value, you're going to have 2. Okay, so you always start with the range of the original graph. Right, the range of the cos graph goes from negative 1 to 1. And now because it's shifting 1 up, it's going to go to 0 and 2. Right. And so the computer, are you okay? Okay. For number 4, you can look at that one. So now I'll move to the side example number 2. It was tan x, which is then shifting 45 degrees right. So also x minus 45 and 2 units down. So this would also be a 2-mark question. You won't get more than one of these in a text like that, unfortunately. And that was the only thing that they asked you in number 4, was just the equation. Equation on 4. All right, then there is number 2. All right, so number 2, they said that G is the graph of sin x, or just G is sin x. Now they're saying that this graph is shifting 90 degrees to the left. Right, so in the negative direction, so it's x plus 90 and it's shifting 1 unit down, so that's a minus 1. Now guys, when it's asking about the minimum value or the maximum value, I'm not sure if you actually did examples like that. It's always the y value. Right, so you have to actually say y equal. Sorry, you might have just said negative 1, but what is that negative 1? It's actually the y value. Right, so just make sure that whenever they're asking for the minimum value of the graph or the maximum value of the graph, what is the y value of that graph? You have to say y equal. Right. So that one, the minimum value of the normal sine graph would be negative 1. So now when it's shifting 1 down, that makes sense that it's 1 next, negative 2. Okay? So it's at negative 1, and now the whole graph is going 1 down. That is also going 1 down. You don't have to write this. Your answer can just be y equals negative 2, 4 marks. Right? We'll just do a 1-mark question that one. That's all you need to write, y equals negative. Okay, exercise 11. So they gave you these 2 graphs, right? I just made some notes on top of the graphs just to show you quickly. They asked for all these coordinates. Now, what I did was I just looked at this point here. Thank you, because this was actually one of 2 points that they gave us. So we have all these many points, but they only gave us the coordinates of 2 of those points. All right, now in order to figure out what all the other coordinates were, you actually need to know what the period of this graph is, guys. Because if you know what the period is, you can figure out what the step is. And remember, the step is just this, it's all of these points, right? So if you know what the step is, you can just say this plus your step is going to be that point, right? And then plus the step again must be that point. All right. So what I did was I looked at this gap here from 50. We agree that that is half of the graph, half of the curve. From the lowest point, middle point, that that's one half of the curve. And then how many degrees is that? From 30 to 210. How many degrees is that? 180. Okay. So here we have that half a curve is 180 degrees. So the period is 60. So the step is 90. So the distance between all of these points is 90 degrees. All right, so that's 50, then that's going to be 50 plus 90, 120. 120 and 0. To get this one, if you're going backwards, you're going to have to say 50 minus 90, negative 60. And then minus another 90, negative 150. And this one you could read off, guys. They're showing you, by using this dotted line, they're showing you that these 2 points have the same y value. Right, so if this one has a y value of 2, that one also is going to have a y value of 2. Okay, so that's how I found the coordinates of T, R, and V. So T is negative 150 and 2, R is negative 60 and 0, and V is 120 and 0. So that is what I wrote for that bit. And if you don't have to write all of that stuff down, you can just write the 3 coordinates, that's fine for marks. I just like writing in. So I said there was half a curve from 50 to 210, which is 180 degrees. So that means that your period is 360, so your step is going to be 90. Okay, it's the normal period of whatever that curve was, the final cos curve. So that's how I got those 3 coordinates. Therefore, G, it was actually quite nice because you could actually read off all of those points. If you have the first 3 points, you could just read off the other ones. So G is this tan graph, right? Now, if you're looking at U is directly below T, right? So if you know that T has an X value of negative 150, U is also going to be at negative 150. But what is this Y value? If that's negative 2, what do you think that one is there at U? Negative 1. Right? So if you know what this X value is, you can see that they're just in line there. So U was the point, let me just make it. U was the point negative 150, negative 1. You didn't actually have to do any calculations to get the points on the tan graph. What about Z? You see that Z is just above this 30 degree point. So Z also has an X coordinate of 30, but what is the Y value of Z? 1. And then the last one was W, which is just underneath or below 210. So W also has an X value of 210 degrees. And the Y value is. Okay, so you have to do calculations to get the values of the blue points, coordinates, but then the red one you could actually just read them off. So maybe guys, before we could jump into doing a whole bunch of calculations, see if you can actually read it off on the graph. Okay, sometimes you will be able. All right, we then had to find the equations of the graph. So there were 2 trig graphs and then these 2 straight lines, right? J and H. And guys, if we're just looking at this, H is at 120. So what is the equation of H going to be? X equals 120. All right, this is an asymptote. Okay, so the equation of H is going to be X equals 120. What about J? How can I figure out what that X value is being? J. We have that this is negative 150, right? What did we say the step of this graph F? The step was 90. So this is at negative 150. How am I going to get that value? Because that's the next point, right? That's one step further back. Negative 150 minus 90. So this is going to be at negative 240 degrees. Okay, so J is X equals negative 240. So I'll just show you where I wrote those. There we go. There's H and there's J. Those are the two equations. X equals 120 and x equals negative 240. Okay, so just write that down. Then the other two were a bit more complicated. All right, if we're looking at the sine graph, guys, we can definitely tell, what did I say? I said, oh, I have an equation here for sine or for cos. So if you decided that this is a sine graph, right? Remember, sine graph starts at the middle value always, because that's the origin usually. You see that that is now that point. That point over there, R. That's the new starting value. But that is at negative 60. Do you guys see why I have x plus 60 in my bracket, right? Because it's a sine graph that shifted 60 degrees to the left. So that's the x plus 60. But now let's look at the direction, guys. We know from our starting point, the sine graph normally goes up. This one from the starting point is going down. Right? So that's why there's a negative in front of my a value. And is it going down by 1 unit? We can see that it's going down to negative 2. Then it's going up to positive 2. So the amplitude is actually 2. All right, so you need to put a minus there. You'll get a mark for having a minus, for recognizing that the direction is the other way around. You'll get a mark for recognizing that it's not going to 1 and negative 1, but it's actually going to 2 and negative 2. All right, that's the amplitude. And then the x plus 60 is you could have moved 50 degrees to the left. You also could have said though that it's like an upside down cos graph, right? If you wanted to say that, let me just erase this. If you decided that this is the starting point, okay, you could have, there's nothing stopping you from doing that. That's the starting point, right? That would make it a cos graph. But we know that a cos graph always starts at the maximum value. This one is starting at the minimum value, or at the lowest point, which is why it would be negative. The amplitude is again 2 because it's going from negative 2 all the way up to positive 2. But now how many units did it shift? Instead of being at 0, it's at 30. So 30 to the right. So that's why it's minus 50. Then you could have used either one of these two formulas, and we'll go through now. All right, for G, this is the other one that you have to find the equation of. Guys, if we're looking at this graph, where does the time graph normally start? At the origin as well. Hey, this one is starting at negative 60. So that is the starting point of the tan graph. So it's going to be, if it's starting at negative 60, what's going to be in my brackets? X plus 60. Oh, guys, it's like pulling teeth. Negative 60, so in the brackets, it's going to be x plus 60. All right, it's going up to 1 and down to negative 1, so my a value is 1. But we need to figure out the period. What did we say this was again? This was x equals negative 240, right? And this one is x equals 120. You know, from asymptote to asymptote, that's one period, right? So that's how we can see the period of this graph. We need to know what the k value is. That's why I need to find the period. Now, what is the difference between negative 240 and 120? 360 degrees. Okay. What is the period of the tan graph normally? 180. Right? It's double. From negative 240 to 120, that's 360 degrees. So I did that whole calculation again. I said, okay, there's half a curve. Actually, let me change this. We're not talking about half a curve. Let's rather talk about the whole period. Was 360. Right, 360. This was from, sorry, from negative 240 to 120. Right, remember the other day we wrote the different ways in which you can tell what the period of a tan graph is. So we actually did have two asymptotes. So you could have checked what is the difference between the one asymptote and the next. It was 360 degrees, and then you use that formula, guys, which we've also written down. The period is 180 over k. So you move the k over to that side, you're left with 180. So to get k on its own, you need to say 180 divided by 360. which is then 1 over 2. All right, so k is a half. So that is where that equation comes from, guys. Your k is now in front of the bracket. All right, so your k value, which is a half, is in front of the bracket, and there we have our x plus 60. That was our shift. When we move to negative 60, so we have to have x plus 60 in the bracket. And we just add. All right, guys, the next question was an interesting question. They asked us for the length of TU. Now, TU is not actually drawn in there, but does it make sense that it's from that point to that point? Like if you had a straight line there. See if I can actually draw one in. Okay. That's TU. All right, now we can tell what the length is there just by looking at the graph. Okay, they've even split it up into like sections for us. That is 2 units, so that's at 2. And that is 1 unit, so that's at negative 1. Does it make sense that this is 3 units? Right, you're just taking from 1 to 2 to negative 1. That is 3 units altogether. All right, so you didn't actually have to do any calculations for that one. You could just raise it all on the graph. From T to U, that's 2 units there. I know that because that point T has a y value of 2. So that means that that is 2 units up. U has a y value of negative 1, so that is 1 unit down from there. So altogether, that is 3 units. All right, so I wrote here 2 plus 1, but you actually could have just written TU equals 3 units. That's fine, we get full marks for that. Then for 3.4, the last question that you had to do, they said that f is now shifted 30 degrees to the left. What is the new equation? Now, I have 2 equations here for f, so we're going to do it for both of them. 30 degrees to the left. To the left is in the negative direction, right? How do we normally indicate a shift in the negative direction? By saying plus. All right, so we're going to take this equation that we have already, and we're going to plus 30 in the bracket. Okay, so you can see what I did there. I highlighted it. So now it depends on which formula you wrote down for f or which one you got. So the other answer is next to this one. So if f is shifted 30 degrees to the left, you need to remember, guys, that that is a plus 30. So whatever you have in your brackets, you're going to add 30 degrees to it. Normally there's just an x, so we would make it x plus 30. But now there's actually an x plus 60 already. So we need to add 30 degrees to x plus 60. Okay, because this was the equation of f already. Now they're saying that graph of f has been shifted another 30 degrees to the left. All right, so instead of having a point at negative 60, it's actually going to have a point at negative 90, which is what this equation is telling us. Oh, this is Olive. You can give it to her. All right, guys, does that make sense? We haven't actually seen something like that before, but you are able to do that. Okay, if you're shifting 30 degrees to the left, you always add 30. But now we had a bracket already, so we're adding 30 to the x plus 60. And then the same thing on the other side, if you use this formula, right, the cos formula, then you would have had x minus 30 in the brackets. Now you have to add 30. So 30 degrees to the left is plus 30. And now in this case, minus 50 plus 50 is the 0. Okay.